This is going to be section 24.2. This is going to be titled The Electromotive Force. It is the force of magnetic fields. And magnetic fields are going to be represented by the capital letter B. So this is a force that's generated by electrical currents that create magnetic fields, and those magnetic fields cause things to move. That's what this electromotive force is. So we have this electromotive force, and the force is going to be a capital F like this. And if you have two magnets, so if you can draw two magnets, one kind of on top of the other like this. So here is going to be a bar magnet, and here is going to be another bar magnet like this. Okay, let's go ahead and identify the north and the south. So this is going to be a north here and a south, and it's going to be a north here and a south. What we have is we have the direction of the magnetic field going from the north to the south. If you remember, we've drawn this before with the magnetic field lines coming out of the north, and then those go everywhere like this. But we're going to be particularly looking at what it exists between these two magnets right here. So if you put a wire between these two magnets, there'll be a demonstration of this so you can see this wire. And let's say that the current is actually going in this direction. So the current is going to be moving from left to right. There is what's called the third right-hand rule. We saw the first right-hand rule, the second right-hand rule. This is the third one. And this is how you determine the direction of this electromotive force. That's what we're looking at here, the direction of this electromotive force. So what you have to do is, we're going to be using our right hand again, but instead of curling around this way, we're going to actually have our thumb represent the direction of the current. So your thumb is the direction of the current. We'll put that here. Thumb is the direction of the current. And what you see, these magnetic field lines, these are going to be your fingers. Your fingers are going to go from north to south. So right here, this is the magnetic field that we're talking about here. So this is going to be labeled capital B. Here's the magnetic field. And the fingers are going to be the direction of the magnetic field from north to south. So your other four fingers on your hand, your fingers are the magnetic field, capital B, from the north direction to the south. So in which direction will the force be generated? So we have our current going this way, okay, and then we have the magnetic field going from north to south, so our fingers will be going like this. What you have to do then is you use your other hand, and you put your other hand with a thumb pointing, thumb pointing up like this, and what's going to happen is the direction of the electromotive force is actually going to be coming up towards you like this. So I have a symbol which was used in oceanography when I was taking courses in college. And if you imagine an arrow, and an arrow can be either flying towards you or can be flying away from you. If it's flying away from you, you'll see the tail of the arrow, or like a dart, and that's the symbol of an X, if you can imagine the wings of that dart. If the dart or the arrow coming directly toward you, then you're going to be seeing the point of that arrow or the dart. So the symbol that we're going to be using is going to be this right here. This is not in normal physics books, but this symbol means that the arrow is coming towards you, and this means it's coming up out of the page. Okay, so let's say that we reversed the current. Okay, with this, we can draw the same setup, but we're going to reverse the current. So we draw your two magnets. Everything else is going to stay the same. North, south, north, and south. Our electric field still goes from north to south. The only thing that we've changed is the current is now running in the opposite direction. So let's follow this, okay? Our fingers have to be pointing from north to south, but now my current is not going off in that direction, it's going off in this direction. So it's kind of hard to see, but if you take your hand now in the direction that it's pointing, it'd be like this, pointed down like that. That's the direction of the current. This is the direction of the magnetic field, and it is pointing down. So we represent that with this symbol right here. Since it's pointing down, this is going to be the arrow or the dart that's going and moving away. So this is going to be down into the page. And this is the electromotive force, and this is the electromotive force. With this setup, it's going to be coming towards. With this setup, it's going to be going away. So what's going to happen to the wire? The wire, in this case, with this current, the force is going to be pushing the wire up. In this case, it's going to be pushing the wire down. So your thumb is the direction of the current. Your fingers are the magnetic field from north to south. And then after that, you have to have your hand placed in like this. Okay? And there is some calculation to this, and this electromotive force is dependent upon a few things. The force is dependent upon the strength of the magnetic field, which is this right here. It's also dependent upon the strength or the size of the current, and it's also dependent upon the length of the wire. So here's your magnetic field, here's your current, here is the length of the wire. The length of the wire that's experiencing this magnetic field. So in this area right here, that would be the length. So if you have more magnets, the length of the wire actually is going to increase as well as the strength of your magnetic field. Okay, so that's one of the setups, and what I'm going to do is I'd like you now to take a look at the two demonstrations that I have created for you, and then we'll continue.